Hello. There are three major kinds of joints in the body. There are synovial joints, which contain a joint capsule, and within that joint capsule is synovial fluid. Synovial joints allow free movement, and most of the joints that you can think of in the body are synovial joints, like your jaw, for example. That's a synovial joint. Fingers, synovial joints, wrist, elbow. Okay, most of the joints, right? But there are other types of joints that don't allow as much movement. We have the fibrous types of joints and cartilaginous types of joints. The fibrous types of joints are the ones that I had mentioned in previous videos, like the sutures and the skull. I had mentioned the little wavy lines that hold the skull together. They do not produce much movement, and they do not have a joint capsule. They are fibrous. They do produce a little tiny bit of movement, but it's negligible. We also have cartilaginous joints, and this is a place where cartilage meets bone, and you have a little bit of movement, but again, you don't have the kind of movement that you find in a synovial joint. So what we're going to talk about today are the 6 kinds of synovial joints, and they're defined by the type of movement that they produce. This is on page 34 in your textbook. We're going to start the screen share here. And here we are, the types of joints. So a joint itself is called an articulation. So I do use these words interchangeably. I use articulation to mean joint and joint to mean articulation. Just fair warning. So the structure of a joint determines its function. But as I said, these are all synovial joints, so they all have a joint capsule and they're all freely movable. They just have different kinds of movements. So we start here with a ball and socket joint. It's what it sounds like. It is a spherical ball type articulation point with a cup-like articulation point, or dish-shaped, the book says. So this type of joint is capable of movement on every plane. So the sagittal, the frontal, and the transverse plane. So your shoulder is an example of a ball and socket joint, and you can see you can do all kinds of movement. You can do flexion and extension and abduction and adduction and rotations of all kinds. So the ball and socket joint is the most freely movable of all the joints. And the shoulder is an example. All right, then we move on to the ellipsoid joint. An ellipsoid joint is a joint that has the oval end of one bone articulating sort of with an elliptical dish of another bone. And basically what happens in an ellipsoid joint is it allows an oval shaped movement. If you think of an ellipsis as an oval shape, it's not really a circle. That's the kind of movement that can occur at an ellipsoid joint. And an example of this one is the wrist, because the wrist allows an oval shaped movement. So if I put all the movement together of my wrist, it's a combination of flexion, extension, abduction, and adduction. And it makes an oval. I can't make, I mean, I could try, but I can't make a perfect circle with my wrist. Okay, so that's a really good example of an ellipsoid joint because you can actually see the oval when I do it, right? This is technically called the radiocarpal joint. Okay, radiocarpal joint. We're going to start using the technical terms for these joints. The shoulder is the glenohumeral joint. I forgot to mention that. Next, we have a hinge joint, and this is pretty self-explanatory as well. It's like a hinge on a door, okay? Hinge joints allow only flexion and extension. So they open, they close, they open, they close like a door, right? A good example of this is the elbow. You can see that right here. and that is the humero-ulnar joint. The humero-ulnar joint. Okay, this is the humerus bone. This bone right here is the ulna. It's the humero-ulnar joint, and it's just a hinge. The knee is another good example of that, and that's the tibiofemoral joint. Next, we have the saddle joint, and this one actually kind of looks like a saddle. It's a modified ellipsoid joint. So we have some of the kind of movement of an ellipsoid joint, but not all of it. It's where a concave and convex surface meet like this. They fit together. So the thumb is a good example of this. It's the trapezium of the thumb articulating with the first metacarpal of the thumb here. I'm not going to give you the joint name because it's long. But anyway, it kind of goes like this. You can't see that. It goes like this. Okay, so it's actually right here is that joint. And it makes a bit of an oval shape. You can see, I can do an oval here. But that's a saddle joint here. Next, we have a gliding joint, and the gliding joints are basically two flat surfaces that glide past one another. You find these in the carpals of your wrist and in the tarsals of your feet. So these little tiny carpal bones are right next to one another, and they just do little tiny gliding movements. So they don't move a whole lot, but they are synovial joints. So really only shifting movements is what your book says. So I can't show you what that looks like because they don't move a whole lot. Then we have a pivot joint. Pivot joint allows rotation, but more specifically rotation within the spine. So a good example of a pivot joint is right at the top of the spine. It's cervical vertebrae 1 and cervical vertebrae number 2, and it actually sits together like this. Okay, so there's a little piece on C2 that C1 fits on, and it allows this rotation or pivot movement. So pivot joint allows you to do this. Just shake your head no, right? The name of that particular joint, C1 over C2, is the atlantoaxial joint. When we get to the upper cervical spine, I'll explain more about that. Okay, atlantoaxial joint. All right, those are the 6 types of synovial joints that you find within your body. And remember, a joint is also an articulation.